Hi, I'm Mann and welcome back to the iVue Robotics channel. Today we'll be learning how to set up mLRS with our Develop Air drones. So what is mLRS? mLRS is this high performance, long range radio system that you can download firmware onto your radios. And the M in mLRS stands for Mavlink, which means you can connect it to Q-ground control, mission planner, or even our own application, World's iVue. Basically, it just means you can connect your controller to your drone. The first thing we'll be doing is our setup process and everything you need for it. So you're gonna need a screwdriver. You're going to need your mLRS 30TX module kit. And you're also going to need just the mLRS 900TX by itself. The end product will look like this, by the way. So first, let's get to unboxing the mLRS 930TX module kit. Here's what's in the box. First off, there's the fan. So when it gets overheated, the fan will automatically turn on. It comes with two radio antennas, a male and female one, whichever one you think you'll need for the radios you already have. Screws for the 3D printed enclosure, which I'll be showing later on how you can get, and the module itself. So first, I'll show you where you can get the 3D printed module enclosure. What you want to do is you want to head over to the Maytech website. You want to go to your product section. You want to go to the mLRS RX and TX series. And then you want to go down and head to the mLRS 900TX module kit. Once you get there, you can scroll down and you'll find in the download section the Junior Bay Case 3D print SDL file. You can go ahead and download that and then 3D print. After you have that printed, you'll have something that looks like this. What you'll need are the screws that came in the box. The first thing you want to do is put this in the back of this. Here you have the screw holes that you want to screw into. After you have that done, you'll see here there's the fan pin port. What you want to do is you want to plug in the pin from the fan into there. After you have that plugged in, what you can do is you can take the top of this cover. You'll see that there are 4 holes, just like on this one, and you want to screw in the fan like that as well. After you have that, what you want to do is you want to choose the radio antenna connector that's right for you and plug it in to the radio port here. It's kind of small, but you'll see it's right there. After you have that plugged in, you want to take out all of the screws from the radio antenna and place them in the same order that they came out as. What you can do now is place the antenna through the hole and then place the outside box on top. After you have that placed on top, you want to use the remaining screws that you have and place them in the 4 corners, like so. Now, once you have that set up, the next thing we'll be doing is setting up the firmware for the radios. So what you want to do is also take this radio as well. If you don't want to use a controller, you can also use this and plug it into the USB-C port of your computer and also connect the drone via your computer through Mission Planner, Q Ground Control, or World's iVue. The first thing you want to do is go to the mLRS XYZ Flash website. The version you want is version 1.3.04, and the firmware you want is the TX Maytech MR930 default version for the one you'll be plugging into your controller. After that, you plug it into the port. You hit connect. It'll pop up as DFU and FS mode. You'll hit connect, and then you'll hit install mLRS. Okay, so now it says done, go fly. All you can do is unplug the USB-C port. For the other option I was talking about, if you don't want to plug it into a controller and you just want to use it with your laptop, it's essentially the same process. If you see here, there's a button on this radio. You want to hold it down, and while you're holding it down, you want to plug it in. You'll know it has worked if there's no light on the radio. Now, essentially, it's the same process as the one we did previously, except you want to change it to the SIK-TELEM version, or SIK-TELEM. So I'll click that, I'll click connect. The same thing will pop up, DFU in FS mode. I'll click connect, and I'll hit install. Now it'll say the same thing, done, go fly, and that's when you know it's worked and you can disconnect it. The next thing we're going to do is set up the controller for the enclosure. So the controller we'll be using is the Radio Master Boxer. It's easy to set up, and we'll be also installing a couple of files onto it to help it support with the mLRS system. Here's the controller. We're going to take off the guard, the plastic guard on it. And we're going to turn the controller on. The way we turn this controller on is by holding on the power button.
Welcome to HTX. Throttle warning.
And then just clicking the return button.
Switch warning.
And here you have it. This controller also needs batteries, which you can install by removing this cover. The next thing we're going to do is remove this little black box, which we will be putting this inside. However, before we put this inside, we're going to put back these 3 screws that I previously took off. How I'm going to install it is just by pushing it in, and you'll hear a click. The next thing we want to do is go into the model section of the controller and go all the way to the telemetry and check that there are no sensors right now. The next thing we want to do is go to the setup of the Boxer, which is page 2. Go down and keep scrolling until we see checklist. We'll turn that on. Now that we're done with that, next thing we want to do is set up our Yaapu files. Yaapu is this widget screen that'll help you visualize what you see when you're connected to the controller and the drone. Here's the link for it. The first thing you want to do is actually install the Yaapu files. So I'm going to go back to Yaapu, click on Frisky Telemetry script, and then what I'm going to do is I'm going to click the clone download, and I'm just going to click save. It's going to install the files. After that's done, I'm going to unzip the files to a folder I know I can find. And I'm going to hit extract. All right, so once your files have been extracted, what you want to do is you want to go to the Yaapu wiki, which you can find by going to the Yaapu GitHub, the Frisky Telemetry script GitHub, and then clicking the wiki. Now, since we'll be using a Boxer which has a black and white screen, all you have to do is click installation on BW LCD radios, and then you can follow along with me on here. So here they say you're going to copy the contents of a specific folder to the root of your radio SD card. How are you going to do this? Well, you'll use the same USB-C cable and you'll plug it in where it says USB. Now, there'll be three options. With the select mode, you want to select the second option, USB storage. Once you have that clicked, if you have a Windows laptop, you'll hear a little sound which indicates that your controller's micro SD card has been connected to the laptop. And then you'll see all of the files on your Boxer, as you can see here. So now that we have that, it says to go to this specific directory. So I'm going to do that. I'm going to go there. I'm going to go to OTX_ETX. And then I'm going to click BW_common. And then I'm going to click SD. I'm going to highlight all those files except for the README file. And I'm going to transfer it over to my controller's micro SD card, like so. Okay, this one is saying 2 minutes and 30 seconds. Now, once you have that directory downloaded, and you might need to format the card a couple of times to get it working, we want to download one more directory. So we're going to follow the instructions again, except for this time, we're going to go back to the OTX_ETX folder and choose our resolution. For the Radio Master Boxer, it's going to be 128 by 64. We're going to click that. We're going to click the SD folder, and then we're going to copy the scripts folder into it, but not the README file. So what I'm going to do is go back to our radio files and drag and drop scripts into there. So that was a quick download. Once we're done with that, we can disconnect the USB-C controller from our radio. Once that's done, now what I have to do is I have to go to the MDL page, go to the last page. In screen 1, we're going to click script, and then we're going to click Yaapu 7. Once that's done, we're going to go back to our model page. We're going to go to setup. We're going to go to external RF. The mode currently is set to off. We want to set that to CRSF. That just makes this compatible with our drone. Now that we have that done, we're going to take our drone and set up the drone and pair it with the controller. So here we have our Develop Air. First thing we want to do is connect the battery to the drone. As you can see here, there's the battery connector.
RF signal critical. Stabilize flight mode.
You'll know it has automatically paired when you hear that sound. You'll also know that it's been paired when the green light is flashing on the controller. Now, the next thing we want to do is connect an antenna to the socket of the radio antenna. So here we have one. I'm just going to screw it in. Now that we have that ready, I'm going to plug in the USB-C of this into the USB-C port of the drone, and we're going to set up parameters, specific parameters for the mLRS system on Mission Planner. So here, the Develop Air has a USB-C port right here. So I'm going to plug it in. Once it's been plugged in, I'm going to open up Mission Planner on my laptop. And what I'm also going to do is open up the Google Docs for the parameter lists and everything we need. So, and that will be available on the iVue Robotics website. On the Mission Planner application, I'm going to click Auto, and I'm going to click Connect. It's going to pop up with the connecting Mavlink. It's going to get all the parameters from the drone and all the parameters we need to change. So what I'm going to do is I'm going to go to Setup, Mandatory Hardware, and then I'm going to go to the config screen, and then I'm going to click the full parameter list. It'll load in all the parameters, and then I'm going to open up the Google Docs to the side. Here it says all the parameters I need to change, starting off with the SR1 parameters. So I'm going to go to the SR1 parameter list on here. And then what I'm going to do is I'm going to set rs1_ext_stat to 2. I'm going to set the extra 1 to 4, and then click enter. Extra 2 to 4, extra 3 to 2. SR1 params to 50. SR1 position to 2. And SR1 underscore RC underscore chan to 1. Once we have that, I'm going to click write params. OK. And it's going to say parameters successfully saved. Now what I'm going to do is I'm going to reboot the drone. All that takes is disconnecting the battery and the USB-C cable.
Telemetry lost.
Now all I'm going to do is wait for a couple of seconds before plugging the cables into the drone again. Now I'm going to plug it back in. And then we're going to go back to Mission Planner. You'll see it has disconnected.
RF signal critical. Telemetry recovered.
So we're going to connect it again. While the parameters are loading, the next thing we want to do is install a Lua script for a controller. This will involve you having more customization options with the power of the range system, and also other things like sending RC input and the order of the channels you want inside the actual module. So the first thing we want to do is search up mLRS documentation on Google. We're going to click the first link. And then we're going to see right there is mLRS Lua script. We're going to click that. And it says when using 1.3.04, which is our firmware, we're going to use the Lua scripts found here. So I'm going to open that in a new tab. And I'm going to click the mLRS bw.lua. Here's the script, and what I'm going to do is I'm going to download it to my computer. I'm going to hit save. The next thing we want to do is disconnect the USB-C cable from our drone and connect it back to the USB-C port we found on our controller earlier. It's going to come up with 3 options again: USB joystick, USB storage, or USB serial. We're going to click USB storage again. So here's what we're going to do. We're going to read the instructions. It says it should be copied into the scripts tools folder of the SD card. So we will do exactly that. I'm going to find my file, open it up. I'm going to open up another File Explorer tab. Go to my Boxer files. Go into Scripts, Tools, and then put in the mLRS BW script. There you go, it's been added. Now all we need to do is disconnect the USB-C port.
Yaapu telemetry ready.
And-
RF signal critical. Stabilize flight mode.
And you'll know it has been connected when you go to sys, which is on the top left button. You scroll down and you'll see mLRS-BW. Now, from here, you can update anything you want. The first thing we want to update is going to the RC parameter, which will be a couple of pages after. It'll say RX SND RC Chen. Right now it's set to off. We want that set to RC underscore override. And then I'll hit save. It's gonna save the parameters.
Telemetry lost. RF signal critical. Telemetry recovered.
And once it says telemetry recovered, that's how you'll know it has worked.
Yaapu telemetry ready. Stabilize flight mode.
Now, one of the other things we want to do is make sure our Yaapu app also has CRSF enabled. Our controller does, but we also want to tell the software in the controller that it's also enabled. So what we're going to do is we're going to hit the tele button. We're going to click return again, and then we're going to hit the tele button again. Now, you'll see a settings screen. You want to scroll all the way down until we see enable CRSF. On default, that's set to no. We want that set to yes. Once you have that, you'll hit return again. You'll go back to the tele screen, and you'll know it's working when you move the drone, and the compass also changes on the controller. Once you have that, your setup is mainly ready. One more thing we want to do is we want to confirm that the radio is actually working. So what we want to do is I'm going to connect that again. We're going to go to Mission Planner, go back to our parameters screen, and go back to the SR1 parameters. So as you can see here, the values have been updated, which means the written parameters that I did previously and rebooted the drone with has been saved. Now I want to go to Setup, and then I want to go and click Connect again. Okay, now once that's been connected, it's going to get all the parameters again. And then we're going to go to the radio calibration screen. We're going to move the sticks on the controller. And once we do that, we can see the throttle moving on the green. And if that works, you'll know that the RC override parameter on the Lua script was also changed and working. Now the next thing we want to set up is our flight modes. So why do we want to do this? If you did not want to take your laptop outside and you just want to use your controller and change the flight modes while you're outside, the best thing to do is to have these 6 buttons and change the flight modes like that. So the first thing we want to do is set up the flight mode on our controller side. So what we will do is we're going to go to the model screen. So I'm going to click the model button on the top right of the controller. And then I'm going to go ahead and go to inputs. Now that I'm on inputs, I'm going to go to 06. I'm going to hit edit. I'm going to go to my source. I'm going to click one of the 6 buttons, and it's going to pop up as S3. Now, I'm going to go down to weight, and I'm going to bump it down to 66. Now that's on 66, I'm going to go to the offset and put that to -1. Once that's done, all I have to do is hit the return button, and now go to the mixes, which is the page after that. Now that I'm on mixes, I'm going to hold that down, go to channel 6 and hit edit. Go to source again, hit one of the 6 buttons, go to weight, put that also to 66, go to my offset and put that as -1. Now that we're done, on the mixes side, the controller side of the flight mode setup is done. What this essentially does is, there's a slope of the line and you put that PWM value on the 6 values, and so when it's talking to the mission planner in Mavlink, it'll have it in 6 steps for the 6 flight modes we will be setting up. So now what I'm going to do is I'm going to go to mission planner with the drone already connected to mission planner. I'm going to hit setup, and then I'm going to go to mandatory hardware and hit flight modes. Here you'll see that all the flight modes right now are set to stabilize. We want to set them up specifically for the flight modes we will be using. So flight mode 1 will be alt hold. Flight mode 2 will be loiter. Flight mode 3 will be stabilize, which is already set to stabilize. Flight mode 4 will be auto. Flight mode 5 will be RTL. And flight mode 6 will be land. Once that's done, I'm going to hit save mode. And I'm going to hit complete. You'll see here the current PWM says 5. We want to change that to channel 6 because that's what we set on the controller. So what we're going to do is we're going to go to config. We're going to hit the full parameter list. And then we're going to find the flight mode parameter. Here it is. I'm going to change the FLT mode underscore channel to 6. After I do that, I'm going to hit write params. It's going to say parameters successfully saved. Now, sometimes it may work after you already hit write params, or sometimes you may need to reboot it. In order to check if it works, all I'm going to do is I'm going to hit one of the buttons. So nothing happened, none of the flight modes changed. So what I'm going to do is I'm going to reboot the drone.
Telemetry lost. RF signal critical. Telemetry recovered. Stabilize flight mode. Altitude hold flight mode.
And now we're going to check if the parameters have saved. So what I'm going to do is I'm going to click one of the 6 buttons and see if it works.
Loiter flight mode.
As you can see, the modes are changing based on what we set them in Mission Planner.
Altitude hold flight mode. Stabilize flight mode. Auto flight mode. Return to home.
The next thing we want to do is go up to Setup and confirm again that our radio calibration works. We want to confirm with all of our axes, so I'm going to move each one and I'm going to confirm that it moves along with it. So here you can see the roll moving. You can see the pitch moving on the screen, the throttle, and the yaw. And that was setting up mLRS with our Develop Air drones. If you have any questions or anything you want us to cover, leave it down below in the comment section or reach out to us in the Discord.